Hello, and welcome back to Fireside Math Chats with Mr. Bacallier. I am your host, Mr. Bacallier, and today we're going to talk about some calc free response questions that people have had dealing specifically with end behavior and the behavior of rational functions. So this question sort of gets into the A bit of the AP Calc A-B stuff. They give you a function that looks like this. They call it f of x, and they ask a series of questions about this function. The first question that they ask is, what are the zeros of f? Pretty straightforward, but we want to make sure that we address everything that we need to address here. So zeros of a function are anywhere that the function crosses the x-axis. And the function is going to cross the x-axis if this value is equal to 0. Well, what a lot of you are used to doing is looking at just where the numerator equals 0. That's a good thing to think about. So I could factor out an x from the numerator, so I'd have x squared plus 2x minus 3, in which case I could then factor this into x multiplied by x plus 3 multiplied by x minus 1. Now, some of you might be tempted to just immediately say, okay, so my zeros are at 0, -3, and 1. But you need to be careful because we have to watch out for the denominator as well. We could factor a 3 out of this thing, so we'd have x squared plus x minus 2, in which case this would factor down to 3 multiplied by x plus 2 times x minus 1. And the reason that this matters is because of these annoying guys over here. The fact that x minus 1 is in both the numerator and the denominator means that the value x equals 1 will not be a 0 to this function. Instead, the only zeros that you're going to have to this function are the values that uniquely make the numerator equal 0. So our zeros of f are going to be located at x equals 0 and -3, not at 1. The second question that we are asked in this problem is, what are the vertical asymptotes of f of x? Now, at this point, I now find myself wishing that I hadn't just erased all of my work that I did before, because it would have been pretty handy to have that. Again, the numerator would have factored down to x multiplied by x plus 3 multiplied by x minus 1. And then the denominator factored down to 3 times x plus 2 times x minus 1. And those canceled. Now the fact that they canceled also means that we're not going to have a vertical asymptote at 1 because we have a hole at 1, which means that my only vertical asymptote is going to occur at x equals -2. Now I'm not going to erase things yet until I read part C. It says the end behavior model of f of x is the function g of x. What is g of x? Well, g of x is whatever this function is going to behave like as x gets bigger and bigger and bigger and bigger. So we're taking a cubic function and we're dividing it by a quadratic function. And we're asking, as x gets really, really big, what is g of x going to act like? Or sorry, what is f of this thing divided by this thing going to act like? So to write this out, it says the end behavior model of f of x is g of x. What is g of x? Now, one way that you could do this would be to do division. You could take your numerator divided by your denominator and anything that ends up in the remainder is sort of going to be noise. So if we took x cubed plus 2x squared minus 3x and divided that by 3x squared plus 3x minus 6, what will we multiply 3x squared by to make x cubed? Well, that would be 1/3 of x. What will we multiply 3x squared by to make 2x squared? Or, sorry, I'm getting ahead of myself. So we take 1/3 of x times 3x squared would be x cubed. 1/3 of x times 3x would be just 1. X squared. And 1/3 of x times -6 would be -2x. We would change our signs, and we would end up with x squared minus x. And so then the question becomes, what do we multiply 3x squared by to make x squared? And that would be 1/3. Now all the rest of this is going to amount to being my remainder, which means that all of the rest of this we don't really care about. And what all of this tells us is that this function is what this function is going to behave like, which means that as x approaches infinity, it's going to behave more and more and more like 1/3 of x plus 1/3, which means that that is our answer to part C. Part D of this particular question asked, what is the limit as x approaches infinity of f of x, and what is the limit as x approaches infinity of f of x divided by g of x, which we had to find right here. So if we want the limit as x approaches infinity of f of x, well, this is a cubic that's growing, this is a cubic that's growing, and this cubic is growing faster than this cubic, which means that this function is just going to keep on growing and growing and growing. And so the first question is pretty straightforward. That limit is going to be infinity. The second one asks, what's the limit of this whole thing? So this part divided by this part, and now we're dividing by an extra 1/3 of x plus 1/3, which means that what this function is actually going to end up looking like is, I'm running out of board space, so I'm going to erase some of this and try to leave the work that I care about. I'm interested in the limit as x approaches infinity of x cubed plus 2x squared minus 3x over 3x squared plus 3x minus 6 over 1/3 of x plus 1/3. Well, think of this a couple different ways, but one thing that I could do is, since I'm dividing by this thing, I could multiply by 1 over it. So really, it's like this thing is multiplying by 1/3 of x plus 1/3. Then I can think, well, what would happen if I distributed all of this out? I would have x cubed plus 2x squared minus 3x divided by 3x squared times 1/3 of x would be just 1x cubed. And then I'd get a bunch of other stuff. That bunch of other stuff I don't really care about. Because when I'm looking at end behavior, these terms are what's going to dictate all my end behavior, which means that I really have a rational function with x cubed over x cubed as x approaches infinity. This thing is going to grow just as fast as this thing is going to grow, which means that the limit as x approaches infinity of f of x divided by g of x is going to equal just 1. Because the degree on the top is equal to the degree on the bottom, you take the quotient of the lead coefficients. That last C and D got a little bit nasty. Hopefully it wasn't too bad for people. If you want to see the original, what that question looked like, let's see if I can. There you go. You can get a look at what that original problem looks like. Maybe I should have done that at the beginning of this. That would have been more forethought than I am known for. But that should give you a little bit more clarity in how to deal with that free response question. Hopefully people are doing okay with all the prep that they've been doing, and you're feeling more and more ready for this. If you haven't heard for some reason at this point, it looks like the test is going to be probably 3 free response questions. You've got 45 minutes to do them. But we still don't have a date on when that's going to be. But I hope everybody's doing okay. I hope you're staying sane, doing some math, maybe doing some other academic stuff. It's not just math that's important, I guess. Some other people say that. But I look forward to a time when I can see you all again, and hopefully that will be soon. Be well, everyone.